Okay, so we are going to put our first and last name on our paper. Today's date is the 5th. This week, the assignments that we're turning in this week, we got quite a few things, okay? If you haven't turned in the line of best fit worksheet from from before, you need to make sure you turn that in. Line of best fit. It's on week 8 page, so you don't have to hunt for it. If you haven't done that, you need to make sure that you do that. If you forget how to do line of best fit, please go back and watch the video from week 7. Okay, week 7 video. I think it's either Friday or Thursday or something, but it's week 7 video. Okay. The other thing this week, we have our warm up. Our warm up is only 2 days. It's today and tomorrow's warm up. So it's warm up 3 because it's Wednesday, and warm up 4 for Thursday. Okay. If you ever miss a day, remember to watch the daily videos. Okay. Please watch the daily videos if you miss a day. The other thing that's due is going to be the study guide. There is a study guide that you are going to have to submit. Now, there's a video that you're watching. It's pretty lengthy, but it's for 2 days. It's for today and tomorrow. So with the video, if you want to do the whole study guide in one day tonight, that's fine. Watch the whole video. But if you want to break it up, stop in the middle, go to maybe number 8, that's halfway through, and then do the other 8 on Thursday, you can do that. Or you can just watch the whole video. But you have to watch the video because that's what your test is on. So that's a part of your homework today. That is your homework today, is to watch that video. So help video for study guide. That's your homework for tonight, okay? You can go ahead and get it all out the way, or you can break it up into 2, okay? Wednesday, today we're going to do our warm-up, okay? After which we're going to go over, I'm going to introduce or do residuals with you today. You have a guided practice that we're going to do. This is going to go in your interactive notebook. Your guided practice is going to go in your interactive notebook also, okay? And then there is an independent practice. Well, actually, I think I might let you work with a partner. We'll put independent for right now, depending on the behavior, okay? You might be able to work with a partner, but this is for a grade, okay? This is for a grade. All right. Again, your homework for tonight is the study guide. You should already have the study guide because I gave it to you already. Okay? I gave you the study guide, but like maybe when I came back. So you should already have that study guide. If you don't, I have another copy. I don't know how many more copies. I know you need a copy because you always lose it. If you have, I only have limited amount. Okay? I only have limited amount. You can always go online and print it on Canvas. Okay? If you have a printer at home, you can print it. Or you can print it. Okay? But I can't print it right now and go get it. I only have maybe about 4 or 5 left. Okay? All right, so please watch the video. And this is for both days. If you go ahead and get it out the way, that's perfect. You don't have that to worry about tomorrow. But you have to watch the video because that's how you prepare for the test. The test on scatter plots and all of those things will be Friday. Okay, any questions? Anybody lost? Okay, good deal. All right, the essential questions I just put on the front page. I thought it was kind of convenient. So let's do the warm-up. Let's do the warm-up. Applause for the cause. Guys, I don't want us talking. I want you to really think about how to do these problems because this is all of stuff that you should already know how to do. If you don't know how to do it, then you got a lot of work to do, okay? But this is old stuff that you should already know how to do. Minus the second one. The second one, I'll show you how to do that one in the calculator. But you can skip number 2 for now, but all the other ones you should know how to do. I am not going to give you the answer to number 4, okay? So you need to make sure that you're doing your work because I'm not going to spoon feed you, okay? All right, I'm going to pause for the calls. Yes, baby. Okay, yeah, come get one, please. All right, so let's look. This is like I was telling Caleb, this is a literal equation. Literal equations is where you have more than one variable within an equation, okay? And there are more than one variable here. It's asking you to solve one of them, though. The one that's asking you to solve is x. So that means we got to get x by itself. So work on the side that has the x. What do we get rid of first, the p or the positive 3? How do we do that? Subtract 3 on both sides. You remember this now? Yeah. Okay. So this is gone, and we're left with px is equal to k minus 3, because k was already there, right? Now what do we do to get x by itself? What do we do to get x? Yes. Divide both sides by p. So this is going to be x on this side is equal to this, k minus 3 divided by p. Okay. Any questions? All right. Anybody lost? Okay, good deal. Let's look at this as given, okay? It says, for which x value are both of these y values the same? Remember, f of x is y, g of x is also y. Please make sure you go back and read your notes on f of x and stuff like that, okay, if you've forgotten. So what is the x value when these y values are the same in both of these equations? So look, this is what you do, okay? Let's clear our calculator out. Second plus 712. Second plus 712. Okay. Second plus 712. And we go to y equals. This is y equals right here. Is there anyone that is lost? Okay. We're going to type both equations in. Let's type in this one first. 3 to the x power. Let me pause real quickly, okay? Answer the phone. All right, here we go. So now we're going to type in this equation. We have 3. And if we want to do the exponent of x, watch what Miss Reyes does. You see this button right here under clear? This is called a caret key. Don't ask me why it's called a caret key. That's just the name of it, okay? But this is how you type in an exponent that other than 2. So you press the caret key, and whatever you press after that is raising it to that power. So now x is right here beside the alpha button. Do you see that? So that's 3 to the x power. Now let's type in the other equation. Negative 2x plus 13. Okay, make sure you type those two equations in. All right, any questions about how to type anything in? Is anybody lost? Yes, baby, go ahead.
I don't know where the X is.
The X is right beside the green button.
Hey, do you have a Janaea Smith?
They already asked me. I don't.
But they were making sure that everybody heard the right name.
Yeah, okay. Janaea.
Does anybody know who that child is?
Yeah.
No.
Do you know who it is?
Do you know where she is?
You don't know where she is, though. Okay. Sorry, baby. All right. So now we're going to look at the function table, okay? So let's go to second graph. Now we're looking to see when the y's are the same. At what point, what x value is going to make the y's the same? 2. You see it right here. So your answer is going to be 2. X is equal to 2. Okay, what y value is it? It's 9. So if they want to know the solution for this, where do they cross each other? The solution will be 2, 9. This is the actual solution. Okay, that's where they actually cross each other. But they wanted to know the x value, which is 2. Let's see, y'all. Okay, so let's look. The next one, okay, number 3. It says a pizza restaurant has a fixed expense of 1,000 per week, plus the ingredients cost of $2.25 per pizza. The restaurant sells pizza for $10.25. How many pizzas does the restaurant need to sell each week for it to break even? All right, so let's write an equation. See if you can write an equation. Can anybody write an equation for this? What would be what's the automatic amount? 1,000. Is that plus or minus? Minus. Okay. As it says, each sale to break even. Yes, that's gonna be minus. So what's your M? Very good. It's $2.25. So y is equal to $2.25 x minus 1,000. Okay, so now let's think about it. It says that the restaurant sells pizza for $10.25. Okay, the restaurant sells the pizza for 10. So, look, how much of a profit is that going to be if it takes this amount? If it takes that amount to just make the ingredients, which should be a negative, really, because that's what it's taken to make it. How much profit are we getting off of each slice if they're charging $10.25 for it? Yeah, how do you figure that out? You do $10.25. Very good. So they're making $8 off this. So now can you write a new equation for this? If they're making $8 off of it, positive $8. What's the equation now? Y equals what? No. 8x minus 1,000. Okay? Because this is how much you're making off the pizza that you're selling. You got it? Because each pizza costs $2 and change to make. If you're selling it for $10, then you're making $8 off of it. Okay. So now, what does break even mean? How when you break even, and what does that mean when you break even? What do you think, Dave? Okay, is well, when you make a profit, you make more than what you spend out, right? But what does break even mean though? What does it mean to just break even? What do you think?
When you make as much you spend.
Okay, so what is that amount?
Zero.
It's zero. So break even is when your Y value is zero. That means that you're even now. Zero. Everything's at zero. Now everything that I make after that is going to be called a what? Profit. Okay. So we got to figure out when is Y equal to zero. How many pieces do we have to sell for Y to be equal to zero? So we're not going to even solve for X like that. We're just going to type it into the calculator. So let's go to Y equals, clear out what's there, and let's type in the 8X minus 1,000. Okay, so now let's go to the function table, that second graph, to see when is Y equal to zero. See, it's right here, it's at negative. So it keeps increasing, doesn't it? For every slice. So look, I'm gonna go to second table set and I'm gonna start at 100. Let's just start at 100, okay? And now I'm gonna go back second graph. So I'm still at negative 200. Okay, so let's go back again. How far you want to go now? 200. Somebody said two. We're gonna do 200 first, okay? Second. All right, 200 pushes it over at a profit already. It's not zero, so we got to go back lower. So we know we're between 100 and 200. So what do you want to go with now? 180. Okay, that's still a profit. Yes, 125. Oh, I'm sorry, y'all. Okay, there you go. 125. So what does that mean? Since x is equal to 125, what does that actually mean? That's how many pizzas you have to sell. Any questions about that? I saw a couple people that got close to that answer. Yeah.
I was 25 off.
Yeah, I saw some couple people that was close to it. All right, any questions? Shh. All right, I'm gonna pause for the calls. All right, good folks. This is gonna be page 18. Again, I think I'm gonna cut your interactive notebook off Friday because like stop for second quarter. So we'll do up to page 20 and then we'll just stop. And then I'll start quarter three notebook after that. Okay. So quarter three notebook we'll start. Quarter three pages we'll start on Monday.
You still haven't opened up that
Which one? Don't worry about it. I got it. I'm sure. I got it. I got it. Don't worry. You talking about the which one?
Then we gotta take the pictures.
Don't worry about that. Don't worry about that. Don't worry about that. Okay. All right. Here we go. Don't worry about that. All right. So we have page 18. Yes, I got an email. Page 18 is residuals. Okay. Okay, so residuals, the overall view. I'm gonna give you an overall view, and then we'll get more in depth. But I'm gonna try to keep it as simple as possible. But if you get lost, just say, Miss Reyes, I really don't understand. Okay. All right. So residual is how far your actual, excuse me, y value are from the predicted. This is just the overview, so it's not going to make sense in the beginning, but as we go deeper, it'll make more sense. Hopefully, it'll make more sense. So it's how far your actual y values are from your predicted y values in a scatter plot. Okay. The residual formula, let's write this down. The residual formula is your actual y minus your predicted y. That's the formula. All right, so that's an overview of what it is. Now I'm gonna go a little bit deeper so that this makes a little bit more sense, okay? All right, here we go. We have a scatter plot. So draw a scatter plot. It doesn't have to be exactly like mine, but try to get close to it, okay? This is your x-axis. You're gonna label this as x-axis. This is your y-axis. We're gonna label this as y-axis. Okay. A scatter plot, by definition, is a comparison of two quantities, okay? It compares whatever you label on your x-axis to whatever is labeled on the y-axis, two quantities. Remember, quantities are represented by numbers. When you compare those two quantities and you graph those ordered pairs, that will show you if there is a correlation or not. If the points go up, that means that the two quantities have a positive correlation. If the points go down, that means the two quantities have a negative correlation. And if the points are kind of scattered everywhere with no way of telling if it's going up or down, that means that those two quantities do not relate to each other at all. Any questions about that? Okay, good. We are going to draw some points going in a positive direction. We're going to make this a positive correlation, okay? And try to do points that are close to mine, but it doesn't have to be precise, okay? This is just an example. Okay? This is just an example. All right. So now the first thing that we do with the scatter plot, if we want to get the residual, is that we have to find the line of best fit. So normally what we do is we use our calculator because that will give us the best line of best fit. We type in those order pairs and do a lean reg. Questions, comments, or concerns about what I said? Okay. But we're just going to draw the line of best fit. Your line of best fit is always the line that's in the center of the points. You have almost the same amount of points on top of the line as you do below the line. That's a good line of best fit. So let's draw a line kind of in the center of the data. I pressed down too hard on my pencils. So maybe somewhere in here. You have maybe 3 points above and 3 points below. That worked out perfectly, okay? Don't always do that. But somewhere in the middle, okay? Doesn't always work out perfectly. This line is called your line of best fit. Other names for line of best fit could be linear model. It could be line of fit. Okay, they all mean the same thing, okay? Or best fit line. There's so many different names. It all means the same thing. They say find the linear model. They're meaning find the line of best fit. Linear regression, they mean find the line of best fit. They all mean the same thing. Any questions about this so far? Okay. All right, so now this again is a positive correlation. And remember, it's a positive correlation because on an average, these points are going up. As X increases, Y is also increasing. Okay? All right, Ms. Reyes, now you need to get to how we get residual. Residual is going to be how far each of these Y values of these ordered pairs are away from the line of best fit. So you see how this point is under the line? So the residual for this point is going to be a negative because it's under the line. The residual for this point is probably going to be 0 because it's on the line. The residual for this point, do you think it's going to be positive or negative? Positive. Why? It's above the line. What about the residual for this one?
Negative.
Why?
Because it's below the line.
What about the residual for this one?
Positive.
Why?
Because it's above the line.
What about the residual for this one?
Negative.
Because what?
Because it's above,
Yeah, it's below the line. And then what about this one? Why?
above the line.
It's above the line. Okay, do you understand that? So residual is how far, the residual for each of these points is how far, the distance from how far it is away from the line of best fit. Well, Ms. Reyes, why do you have predicted Y? Because your predicted Y values are any point and every point that's actually on the line of best fit. Every single point that's on the line of best fit is the predicted Y. Okay, so whatever Y value this is on this line, that's a predicted Y. Whatever Y value this is on the line, that's a predicted Y. All of your predicted Y values come from your line of best fit. So we're going to put a star, a little asterisk, because this is super important. Predicted y values are the y values on the line of best fit. Okay. Any questions about that? Okay, Ms. Reyes. Well, what about the actual y values? What about your actual y values? Your actual y values are given to you. These points right here, they have an x and a y. Well, the y values on these ordered pairs are your actual y. They're given to you. Your actual y values are given to you. Any questions about that? Sometimes you'll see a residual plot that looks like this, where they'll say, you'll see this line from here to here. This line, this is showing you that this right here represents the residual. That's how far this point is away from the line. This line right here, this is showing the residual because this is how far the line is away. This point is away from the line. This is a residual because this line represents how far this point is away from the line. This is a residual. This distance from here to here is residual because that's how far this point is away from this line. This right here is residual because that's how far this point is away from this line. And this is residual because this right here is residual. That's how far this point is away from this line. Any questions about that? Anybody lost? All right. There is a sheet that I gave you. I'm going to do some examples of how to do residual and how to graph residual. And then you're going to do, this is just going to be for practice. But the other sheet that I'm going to give you is going to be for a grade. Okay? We're going to put this to the side. If you need it, then you'll have it out to the side if you need it. All right, let me try to zoom in a little bit. You do need your calculator. Let's clear it. 2 plus 7, 1, 2. All right, first things first, look at this one. Hope y'all good. Oh, you got a question? Y'all okay? Oh, Lord. Okay, linear regress. That's the same as line of best fit. So you didn't even have to find the line of best fit. They gave you the line of best fit. Yes, baby. Uh-huh. They gave you the line of best fit. Okay? You didn't even have to find it. They gave it to you. Any questions? So now you got to find your predicted Y by using the line of best fit. So where do I go, Ms. Reyes? I go to Y equals. Please follow me. What button did I press? Thank you. Just making sure you're listening. So now we're going to type the line of best fit in. That's 0.5x. Any questions? So now, good people, now we are going to view the function table. When he comes back. When this guy right here comes back, babe. Now I'm going to view the function table. So the second graph. And look, now I'm going to find the predicted value for 5. So go down to where x is equal to 5. What's the predicted value for 5? 2.5. Okay, is This point gonna be, is the actual gonna be above or below the predicted? Why you say below? I don't know.
Isn't the predicted value 2.5?
So is the actual above it or below it?
Oh, above.
It's above. There you go. There you go. All right. So your actual is above. Okay. Maybe I should have made that clear. So this point is going to be above the line of best fit. All right. So let's look at 10. Go down to 10. What's your predicted for 10? 5. Is the actual above or below the line of best fit?
It's like in the line.
No.
It's above.
Oh yeah, because the line's supposed
The
to be
actual,
zero.
is it above or below? It's below. How is it below?
5 is bigger than 4.
Very good. Very good. Because this 5 is bigger than 4. Or some people say the 4 is smaller than the 5. Good. Okay. Let's go down to 15. What's the predicted for 15? It's 7.5. Okay. Is your actual above or below? It is above. Okay. Do you see that? All right. 20. Go down to 20. What's that? Okay. Is the actual above or below? Below. Okay. So now look, guys. Go to table set for me, please. Second window. And let's, instead of doing auto, let's do X for independent for your X. So we can just type in our own X values. So press enter on X. Please do that now so you don't be like, Miss Reyes, what did you do? I press second window. Come on, Caleb. Did you hear that? Okay. Did you hear what I said? Okay. All right. So now go back to second graph. Now, the next X value we need is 25. So type in 25 and enter. What's the predicted? 12.5. Okay. And let's type in 30. And what's the predicted for 30? 15. All right. So what do we know about this one? What do we think? It's exact. So what does that mean? It's on the line of best fit. It's on the line. Very good, Coach. All right. So now we are going to find the residual. What did we say the formula for residual was? Actual Y minus the what? Predicted Y. Okay, so that's this actual Y minus this predicted Y. So let's do that. Let's find the residual for each of these X values. So the residual for 5 is going to be 3 minus 2.5. What's 3 minus 2.5? So the residual for 5 is 0.5. Any questions? Got it? And it's a positive. So that means it's the actual point was above. Do you see that? Okay, let's do the next one. Let's do 4 minus 5. What's 4 minus 5? Negative 1. What does that mean? That the actual is below the line. Okay. Let's do the next one. What's 9 minus 7.5? It's positive 2.5. Okay. What about the next one? 7 minus 10? Negative 3. What about, what is that? 13 minus 12.5? 0.5. And what about 15 minus 15? 0. It's right on the line. Okay, so now we're getting ready. Any questions about how I got the residuals for each of those? Yes.
For the 2.5 or the 15 and 9 supposed to be 1.5.
1.5. Yeah, it is 1.5. All right, let's keep going. All right, so now let's graph the residuals.
So just to get it straight, so predicted value is mostly going to be up top, like above the line.
No, okay. Say predicted value. These predicted values you find on the line of best fit. I found those in my calculator. The actual is given to you. Predicted, I went to y equals, I typed in the equation, and I went to, second graph, and I found my y values by using the line of best fit. That's where I get my predicted from. Are you okay?
Yes.
Are you sure? Shh. We'll do another one too, okay? All right, so now, are you sure?
Yes, I got
Okay, all right. So now we're gonna graph, guys. Please be quiet. Don't do that.
it. Okay,
Just
guys.
don't do that. All right, put residual here. Please pay attention to this part because a lot of people get lost on this. We're graphing. They want us to graph the residuals, but not the regular scatter plot. Okay, we're graphing residuals here. So when you graph residuals, you always graph the residuals on the y-axis, and you use the x's for the x-axis. Okay, so these are the two things that you're graphing when you do residuals. All right, if it was a scatter plot, then you just graph these or you graph those, but they don't want that. They want you to graph the residuals. Got it? It says construct, you see right here, residual plot. That's what we're doing. All right, so now let's look at our x's. It goes from 5 to 30. So we got to go up by fives. 5, 10, 15, 20, 25, 30. Do you see that? And for the residual, it's going from -3 to 1.5. So we're going to have to go up by ones. So this is 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. All right, so let's graph this. 5. Please watch what I'm doing. I'm graphing this ordered pair. 5, comma, 0.5. Go over to 5, and 0.5 is in the middle between 1, and if it helps, you can just put 1, 2, 3, 4, 5 here, if that helps. -1, -2, -3, -4, -5, if that helps you. And this is 5, 10. I don't want to write on this because I might need the space. We're just going up by fives here. Okay, so let's do 10. This is 5, this is 10. -1 is down 1. Any questions about how I did this one? Then let's go to 15. This is 5, this is 10, this is 15 right here. 15 and 1.5. So this is 1 and 0.5 is in the middle. Okay. 20 and 3. 5, 10, 15, 20. And -3 is down 1, 2, and 3. Okay. 25 and 0.5. This is 25 and 0.5 is right here. Okay. 30 and 0. This is 30 and 0 means it's on the line of best fit. Okay. All right. Any questions about how to plot or construct a residual plot? No questions? Yeah, maybe. Yes, go ahead. All right. Let's look. Now it's saying, does this residual plot suggest that it's linear? Okay, look. Here, you can tell there are the same number of points above the line as it is almost below. If it's symmetrical, then that means it's a good line of best fit. If you have a whole bunch of points up here, then that means all of the points are above the line of, it's not a good line of best fit. The best line of best fit is going to be one where there are just as many points above this line as it is below, and it's almost an equal distance, because that tells you that the line of best fit is in the center of the data. So is this have a linear relationship? Means it's a relationship. Doesn't mean it's a perfect straight line. And it does. This is a yes. How do you know that, Ms. Reyes? Because it's symmetrical. If it's almost symmetrical, that means that this is a good line of best fit. Yes, because the points are symmetrical. Points or ordered pairs are almost symmetrical. It's not perfectly symmetrical, but you have just as many on the top as the bottom, and they're almost an equal distance of each other. You don't have one way up here and then they're almost symmetrical. Okay? Any questions about that? It wouldn't be linear if you had way many more points on top than you did on the bottom. Any questions about that? Okay. Number 2. Is anybody still copying one? All right, so now I'm going to ask you a whole bunch of questions about number 2. You should be able to do part of this on your own. I'm going to walk you through a little bit. Let's clear our calculator. 2nd plus 7, 1, 2. All right, they give you a line of best fit. So now we have max, we're going to have to find the predicted values, okay? So this line of best fit, we're going to type it in the calculator. Where do we go in our calculator to type this line of best fit, babe?
Second graph.
Okay, no,
Oh,
second.
no, y equals in the second.
Y equals, very good. So let's go to y equals and let's type this equation in. Good job, babe. So that's negative 0.4x plus 16.3. Okay. Everybody good with typing it in? You got questions? Okay. So now if we press second graph, we have to keep strolling down. I like it better when we can just type in the x values because it goes by faster. So press second window, and you see where it says independent? That's the x value. Put it on x. And now you can press second graph and you can type in the x values because it'll go by faster. So the first x value is 2. What's the predicted value for 2?
15.5.
15.5. 15. Woo, that's a long way away, isn't it?
That's right.
Yes, babe.
For the second window, which one do you put on F? The independent or
The independent. Yeah, that's your x. Okay. You want to type in your x value so you can get your y values. Okay. You got it? Did you go to second graph? And then the first number we typed in was 2. Did you get that, babe? Okay, good deal. All right, so look, is my actual point above or below the line? It's below. Woo, it's way below. Do you see that? Okay, let's type in 4. What's my predicted value for 4?
14.7.
Okay, 14.7. Is my actual above or below the line? It's above. It's above the line of best fit. The next x value is 6. What's the predicted value for 6? 13.9. Is my actual value above or below the line? It's above the line. Good. Let's type in 8. What's my predicted value for 8? 13.1. Good job. 13.1. Is my actual above or below the line? It's above the line. Good deal. 10. What's my predicted value for 10? 12.3. Good job. 12.3. Is my actual above or below the line? It's below the line. And then 12. My x value is 12. What's the predicted for 12? 11.5. Is my actual above or below the line? It's below the line. Any questions about that? So now we're finding the residual. The formula for residual is your actual y minus your predicted y. So it's this minus this, and you get your residual. Any questions about that? Do you understand that? Okay. So I go back to my main screen, second mode, and I can subtract. I have 5 minus 15.5. What does that give me? A negative what? Negative 10.5. You see how that's under, the actual is under the line of best fit? Because it's a negative. Okay. Then we got 15 minus 14.4. 14.7, sorry. That's 0.3. It's above the line. The actual is above because it's a positive number. Any questions about how I did that? Do you understand? When you construct your residual plot, your residuals go here. And your X values go here. So we could go up. We probably need to go up by 4s. So this would be 0, 4, 8, 12, 16. -4, -8, -12, -16. And then here, let's see, 2, 4, 6, 8, 10, 12. We go up by 2s. And then you should be able to graph. Any questions about that? All right, y'all. I need you to finish this sheet. This goes on page 18, continued. And I'll give you the sheet for a grade. I'll give that to you tomorrow. Just finish this stuff, okay? Any questions, comments, or concerns? Are you sure? How did y'all feel about that? Was that kind of hard, or you thought it was easy? Okay. All right, cool beans. All right.